This is a Friday Shoes production. Our lesson today is 3-4 on page 155 in our book, and our target is I can identify and classify numbers in the real number system. Let's talk about the real number system. It's made up of two things: rational numbers and irrational numbers. If you recall, numbers that can be written as fractions are called rational numbers. Any number that you can write as a fraction will be called a rational number. Numbers that are not rational are called irrational numbers. And you may have guessed it, if you can't write it as a fraction, then it is an irrational number. Let's take a look down here. It says the set of rational numbers and the set of irrational numbers together make up the set of the real numbers. Real numbers are what we're going to be dealing with in this particular pre-algebra class. To study the Venn diagram below, and here I've blown it up for us here, these are the real numbers. We've got rational numbers, we've got irrational numbers. Within the rational numbers, we have things called integers. We also have things called whole numbers. I'll put a couple up here so you can kind of see what they are. Whole numbers, like 2 or 3 or 7 or 9. Those are whole numbers. Integers include the whole numbers. As you can see the Venn diagram, it actually includes, the yellow is inside of the blue. So all the whole numbers are integers. But what are the other ones in the blue? Well, that would be like -9 or -7 or -2 or -3. Those are integers, but they're not whole numbers. What other numbers? You can see we've got this outer space here outside of those two circles. What goes there? Well, those are the terminating decimals or repeating decimals, like, let's say, 0.5. That's a terminating decimal. Or 7.32. That's a terminating decimal, meaning it ends. Or any fraction that might be repeating, like 1/3 actually is 0.3 repeating. That's a rational number. Any fraction actually is going to fit into our rational numbers here, because that's the definition of what a rational number is. But it's all terminating decimals and also all fractions. Now, irrational numbers. How do we generate an irrational number? Well, the simplest way to generate an irrational number is to take the square root of a non-perfect square number. So the square root of, let's say, 10 is what we call an irrational number, because when we do that on our calculator, you're going to notice that it goes off the screen. The decimal goes off the screen, and there is no pattern to it. It's not repeating, and it doesn't terminate. It's a non-terminating, non-repeating decimal. So the square root of any non-perfect square will be an irrational number. Now, wait a minute. Over on the rational numbers, don't forget, square root of 36 actually is 6. So that is a rational number. That's actually going to fit into our whole numbers, which are also integers and also rational numbers. All right, let's take a look at some examples here and how to classify these. If you're going to name them, is it whole? Is it an integer? Is it rational? Is it irrational? We'll take a look at the first one. You see that that's repeating. It's 25 repeating there. Well, that will make it a rational number. And the equivalent to that, if you remember in class, I told you if it's repeating starting at the decimal, just put 9s underneath the repeating part as far as it goes out. So 25 has 2 digits, so then you have 2 9s. So it's 25/99ths. It's called a rational number. How about the square root of 36? I just told you the square root of 36 is 6. Well, it's a whole number. It's also an integer, because 6 is also an integer, and it's a rational number, because it can be written as a fraction. And it says, when you classify numbers, always simplify before classifying them. That's your study tip there. How about the third one, -7? Well, negative square root of 7, that is equivalent to 2, and they kind of wrote it out there for you. They used a calculator to get that. And since the decimal does not terminate or repeat, it is an irrational number. So you would call that just an irrational number. How about you try these down here and see how you do? Square root of 10. Well, that's a irrational number because this is not a perfect square. So I would just call this irrational. That's the only name we have for it. How about B over here? Negative 2 2/5. Well, it's a fraction, or excuse me, a mixed number. So this is definitely can be written as a fraction. I'll show you. You take the 5 times the 2 and you add the 2 on the top and you got yourself a 12 over 5 and it's a negative. So if it can be written as a fraction, it's rational. It's not a whole number and it's definitely not an integer. How about this last one? Square root of 100. Square root of 100 is 10. 10, got to simplify, so that's why we have 10. 10 is a whole number. It's also an integer. And it's rational because it can be written as a fraction. So 10, or square root of 100, is all three of them. It's a whole, integer, and a rational number. All right, how about graphing real numbers? It says estimate the square root of 6 and the negative square root of 3 to the nearest 10, then graph them on a number line. Well, the book has a good illustration of this. Now notice it says use a calculator. So you use a calculator, calculate square root of 6 and negative square root of 3. And they say the first one's about 2.4 and then the second one's about negative 1.7. So they're placing those on the number line, and take a look at the number line where they placed them. And that's where they're approximately located. So there you go. It's a pretty simple process there. You can read the study tip on your own. How about this? Comparing numbers, the real numbers. Replace each circle there with less than, greater than, or equal to make a true sentence. Well, square root of 7 and 2 2/3. What should we do? Well, write each number as a decimal. And notice they did that. Used a calculator again, and you can as well. And it says since 2.645751311 is less than the other, we have square root of 7 is less than 2 2/3. And they even graphed it for you there to show you. Anything to the left is less than anything to the right. All right, how about number 6 here? 1.5 repeating, which is 1 5/9. How's that compared to the square root of 2.25, which I know I can do in my head because that's 1.5. Because 225 is 15. Talked about that in class. Well, again, let's write these out as decimals. So square root of 2.25 is 1.5, and 1.5 repeating looks like that. So 1.55 is definitely greater than square root of 2.25. And you can see they located it on the graph for you. How about you check your progress here? Square root of 6.25 and 2.5. Well, I know this. The square root of 625 is 25, because I know that 25 times 25 is 625. So the square root of 6.25 is actually 2.5. 2 spots, you only need 1 spot here on the 2.5. So this is 2.5. What about the 2.5? We can change that to 2.5 because we all know that a half is equal to 0.5. Well, look, those are the same. So that's what I would put in between, the equal sign. That's it. Don't hesitate to rewatch the video, or you can look in the book for the examples and use the personal tutors on the online textbook. And as usual, this has been a Friday Shoes production.